The CMP170HX is sold with only 10 GB of memory. But the physical HBM on the package may actually total 80 GB. And this is no longer just a theory. Full-range writes, readbacks, and a zero-error stress test have all been demonstrated. 10 GB is only the factory-exposed configuration. The community has already expanded these cards to a stable 40 GB. The paper's author then wrote unique hash patterns across the full 80 GB and read every pattern back correctly. The test is simple. Write a different hash to every region from 0 to 80 GB, then read it all back. If the upper addresses were only mirrors, earlier data would be overwritten. That did not happen. The entire range was independently addressable. At full speed, the same card completed the 40 GB test with 0 errors. At 80 GB, one GPU burn run reported 2,796 errors. That matches a binned memory part. The capacity exists, but its original timing margin is weak. Lowering the DRAM refresh interval made refreshes more frequent, and the same 80 GB stress test dropped to 0 errors. Throughput fell from 94.6 to 64.6 teraflops, a 32% penalty. So 80 GB can work. The next challenge is reducing that cost. Most public attempts only change CFG1 and LMR, making the GPU report an 80 GB frame buffer geometry. On some 10 GB cards, addresses above 40 still fold back into the lower half, overwrite critical regions, and trigger GSP timeouts or kernel crashes. The aliasing is measurable. Data written near 12 GB can be read near 52 GB plus an offset, and vice versa. The highest address bit is being ignored, so the upper 40 GB map back onto the lower 40. HBM is not an ordinary memory chip. 8 drum dies connect through silicon vias to a logic die at the bottom, where address decoding happens. Tools report 8 GB per stack and 40 across 5 stacks. Full capacity requires the logic die to decode the higher address bit. The production timeline, process node, die analysis, and model identifiers point to the same conclusion. x86 high stacks use native 16 gigabit dies, but expose only 8 gigabit addressing. 5 complete stacks add up to exactly 80 GB of physical memory. First, CFG1 and LMR expose the 80 GB geometry. Second, a vendor-specific WIR configuration must program the logic die and enable the RA14 high address bit. Third, refresh and timing adjustments trade some performance for stability. Together, those 3 steps form the complete solution. The CMP170HX path from 10 to 80 GB is no longer a myth. The physical capacity exists, independent addressing has been demonstrated, and refresh tuning reached 0 errors. What remains is turning the logic die initialization into a reproducible public method. The path itself has already been proven.